The next topic I'm going to talk about capacitors connected in series and parallel. So, how the voltage division takes place, or how the charge on each capacitor. Now, when the capacitors are in series, at any node only two elements exist. Element is nothing but a capacitor in this case. So, if you look at here, I have a capacitor, second capacitor, third capacitor. We label them C1, C2, C3. All these three capacitors are connected to a voltage source V. Okay, how many nodes are there? Node is nothing but a point, two or more elements connected. So here I have node 1, node 2, node 3, and node 4. There are 4 nodes. So if you look at each node has only 2 elements. So I'll say these I can say these elements are connected in series. When capacitors are connected in parallel, all the elements exist between the same nodes. So if you look at these three capacitors, I'm just showing you 3. It could be more than 3 or less than 3. I mean, as long as there are 2 capacitors, we can say those are in series or parallel. Okay, so here also I'm going to label them C1, C2, C3, and source voltage V. Okay, here I have only 2 nodes, N1 and N2. So all the elements are connected between those 2 elements. Okay, now when the capacitors are in series, total capacitance, let me go with the charge. So charge on each capacitor is same. So the first point is, when the capacitors are in series, same charge is same on each capacitor. That indicates that, say for example, this voltage source is supplying Q total. That Q total is same as Q1, same as Q2, same as Q3. Okay, so if we look at a capacitor, okay, this has a positive charge of Q, this plate has a negative charge of negative Q. Okay, both plates will have the same amount of charge but opposite charges. When it comes to the parallel, charge division takes place. So charge division takes place. So that means Q total equal to Q1 plus Q2 plus Q3. So charge is going to divide into 3 parts. Okay. Now here, when capacitors are in series, voltage division takes place. Okay. So when the capacitors are in series, the voltage is going to divide. So here is V total. So V total equal to that's V1. So basically between this node and this node, I have V1, V2, and V3. Okay, so V total equal to V1 plus V2 plus V3. Okay, now when it comes to the parallel, same voltage across each capacitor. Okay, so V total equal to, in this case, V total equal to V1 equal to V2 equal to V3. So if I'm take the voltage across each capacitor is V1, V2, V3. Now we know that Q equal to CV. Okay, so charge on each capacitor equal to C times voltage across each capacitor. So based on this, can I write this as V total equal to Q total over C total, which is V1 plus V2 plus V3. So I can write V1 is nothing but Q1 over C1 plus Q2 over C2 plus Q3 over C3. So Q total over C total. But here we already know charge is same, so the Q total must be equal to, so if I pull out Q1, Q2, Q3, they are the same as Q total, so they get cancelled out. I can say 1 over C total equal to 1 over C1 plus 1 over C2 plus 1 over C3. Okay, so if the capacitors are in series, then the total capacitance equal to 1 over C total equal to 1 over C1 plus 1 over C2 plus 1 over C3. Now when the capacitors are in parallel, so here Q total equal to Q1 plus Q2 plus Q3. So if I use this formula, so C total times V total equal to C1 V1 plus C2 V2 plus C3 V3. But I already know V total is same as V1 V2 V3. So if I separate those, C total equal to C1 plus C2 plus C3. So if capacitors are in parallel, it's going to be direct addition. Okay, now I'm going to, if two capacitors are in parallel, if two capacitors are in series, if two capacitors are in series, 1 over C total equal to 1 over C1 plus 1 over C2, so I can write it as C1 C2 as common, and so C total equal to multiply on the numerator and add them in the denominator. So if two capacitors are in series, this is a common formula I'm going to use. If three capacitors are in parallel or series, sorry, I always get confused because the reason behind it is, if you remember, if resistors are in series, it's a direct addition. If resistors are in parallel, we're going to do the inverse. So that's the reason I'm also a bit confused, or saying in reverse way. If three capacitors are in series, okay, then 1 over C total equal to 1 over C1 plus 1 over C2 plus 1 over C3. So the common factor is C1, C2, C3. So 1 over C total, it's going to be C2, C3 plus C1, C3 plus C1, C2. Okay, so C total equal to multiply in the numerator. In the denominator, it's not direct addition. That's the reason. I mean, many students are going to get confused here. It's C1, C2 plus C2, C3 plus C3, C1. I mean, in the past, I saw students were writing this as C total equal to C1, C2, C3 over C1 plus C2 plus C3. This is wrong. Okay, so if three capacitors are in series, this is the formula. Or what you can do, you can combine two capacitors at a time and again use the same formula to do it. Thank you.